Welcome to the podcast today. My good friend, Christian. He is the co-founder of Mind Network. Christian, before we get too deep into Mind Network, give us a brief background into yourself and how you became the co-founder.
Sure, will do. Thank you. Happy to be here, Jax. Thanks for having me. I'm the co-founder of My Network. I was doing surgical technology, medical device sales for about a decade before I got into crypto in 2021. Started with a deep in project, made my bones in a bull market, and then surviving through the bear market, and became really interested in privacy in Web3, which seemed to be lacking. And I found our two other co-founders for the project, and we started to ruminate on productizing advanced cryptography solutions for the market. And that's how my network came to be.
Absolutely. Well, now that we are getting into Mind itself, tell us a little bit about what the mission is. What are you hoping to accomplish there?
Well, so Web3, very broadly and very high level, Web3 is made for public data. So if Web2 became Web3 tomorrow, your SaaS subscriptions, your grocery bills, where you go all the time, all of this would be public data tied to a wallet, which is pseudonymous but not completely anonymous. And that's a lower standard of security than most people enjoy now in Web 2. So it's unacceptable. It can't move forward. This is a huge problem to solve. And it just so happens that there are there's dozens and dozens of projects in the DECC community, which is decentralized confidential compute. There's multi-party computation being used by some of the best in the industry, and zero knowledge proofs, trust execution environments. Fully homomorphic encryption is this really cool tech that I stumbled upon a couple of years ago because it was conceptual in its inception, which was in the late 70s, early 80s, and then it had this really kind of splash use case in the OOs when it was being used to sequence the human genome, which is arguably some of the most sensitive data. Your genomic data is very sensitive. You get one of those, and so when it was being used, then that was the first use case of like, hey, this actually is applicable. It's not too slow. It works. And so since then, it's been speeding up. And there are FHE departments at Intel and Microsoft and some of the leading tech companies. But there's no decentralized project that are building solutions for individuals to use. And it really is a game changer. It's the most advanced cryptography method that we know today. It's called the holy grail of cryptography. And to put it succinctly, it's the ability to encrypt on or to compute upon encrypted data without decrypting it. So if you look at most of the basically the structure that we have for all of the internet, for all the apps that we use and all the big providers for all the services and the infrastructure and big data storage, I mean, all these massive companies that have built, 100 billion, multi-trillion market caps, the standard operating procedure is that they store your data. You trust them to use the appropriate cryptography methods and data storage, and then you use apps, but you're sharing so much data through these apps. They're storing it for you. You don't really have the ability to secure it yourself, store it locally, privatize it, or stop them from seeing the raw data if you want. Too bad, so sad. Not going to happen. If you're using the app, you're sharing all the data in its raw form. And of course, that's then very susceptible to leaks and to breaches and to misuse and to selling to third parties. So that whole paradigm has probably got to change. And so if that's got to change, and there's been, I think, a call from the market in most countries in the world, we've seen for the last 2 years, this concern over data privacy, data security. You're seeing this kind of tailwind from the retail of hey, we want more control over our data, better privacy protections. The best you're going to get in the Web 2 paradigm is that they will maybe start to use better methods on their end to store it, and maybe they don't sell it to just anybody that's asking in the market or the highest bidder, but it's still not an ideal solution where basically you get to keep it in an encrypted state and demand that they encrypt upon it or compute upon it in an encrypted state, or in some cases, if you want, you can actually store it locally. So those solutions are only going to come from Web3, and that's what we're really excited about building. And we've got a lot of friends in this space like Phoenix and Inco that are offering similar kind of products using FHE. So it's a very exciting technology. I mean, it's as substantial a technology could say as maybe blockchains. It's a real paradigm changer in terms of self-sovereignty and individual economic freedom.
Yeah, I have to say one of the most surprising things is when you learn that like your internet service provider can actually sell all of your underlying data. And
Yeah.
it's just one of the craziest things. You're like, wow, I did all these good things pre. But tell us a little bit about, because you talked about ZK, you talked about trusted execution environments, and then FHE. Can you try to maybe delineate some of those solutions and kind of what separates FHE and like what's the need if we have like ZK, if we have trusted execution environments?
Yeah, exactly. Yeah. So in some case, there's so many use cases for encrypting data. So in some use cases, one of those four might be a better solution for now. So an example would be zero knowledge proofs are really fast and they're very scalable, and the computation happens off chain. And what you're dealing with on chain is a proof, which can move really quickly. So that's great. Um, so there are some solutions where ZK is the better solution, some needs where that's a better solution. There's other needs where actually the data is very sensitive, and you might have a situation where one of the participators does not want the raw data to be seen at all. Now that's a problem if you're only using zero knowledge proof, because whoever is running the zero knowledge proof, who's ever doing that computation, they see the raw data. So there is a trust assumption there. And if that is desired, if that's an undesired effect in the process of sharing and computing on data, then you do need to use FHE. So in some cases, you have more closed environments where there's a kind of a white list of people that will be accessing the data, in which case multi-party computation is used. And by the way, we use all three of these encryption methods in our solutions, because there are some times when decryption does need to happen based on the parties involved. And so we use MPC. Our data storage product uses ZK for input and output because it's faster. So in some cases it's a blend, in some cases it's just the one. But where FHE is not great right now is that it's slower, so it's not performant. The computation is really, really, it's good for like basic computation, which is why we've productized around basic computation, so that it can still be fast, a matter of a second or less. Once you start getting to like multiple seconds and even minutes, you don't have a viable solution for the market. So you still might need to use ZK and kind of create these hybrid solutions, but it depends on what the application is.
Yeah, and I guess for people that are not as familiar with fully homomorphic encryption, or like why you would need to encrypt things on chain, essentially, like let's imagine like a poker game. You wouldn't want to be able to see like everyone else to be able to see other people's hands. So talk
Right.
to us a little bit about like the computations that fully homomorphic encryption like works well for. Is it usually just with like specific numbers or like addition, subtraction, those types of
Yeah.
operations, or what kind of operations is like fully homomorphic encryption good for?
Yeah. So addition and subtraction is really easy. The best use case right now is that we found so far, that's like the biggest addressable market, is basically in encrypting the consensus between validators or nodes. And so this is like the one of the greatest paradigm shifts from Web 2 to Web 3 is it's in decentralization. You need consensus all the time. You're constantly having to come to consensus because there's very rarely, if ever, just a single decision maker. Well, if all of those validators or nodes or all those decision makers are publishing their results publicly to a chain, you have a lot of issues with that. And of course, in the big chains, you've seen slashing and time bombing to try to stop these problems. In insufficiently decentralized networks, they work fine. But a lot of the new projects that are coming out, whether they're L1s or L2s, are not sufficiently decentralized. They have to start out small because the attack vectors are high and the risk is really high when you're first starting out. For example, all the AI networks essentially are like brand new L1s. So they don't have a real distributed validator base. And they have a kind of validator. What we discovered contributing to BitTensor early was they had this model where validators and miners, the two sides of this kind of AI structure, where you have miners that are hosting models, making models, then you have validators that are ranking the models. Now they'll rank the models on the criteria that is put forth by that subnet, but they are publishing their answers publicly so everybody can see them. And so if you can see a validator has got, a million DAO tokens, which is the native BitTensor token, then you can see that, well, probably have a lot of resources. They probably have a lot of access to compute, a lot of money. So that means they're probably likely to get the answer right to verify this model. So the other validators would say, well, instead of doing the work on my own, why don't I just copy the lead model, or the lead validator rather? And they would, and there was a lot of copying. And so that kind of defeats the purpose of decentralization. And so what we did was say, well, if you just encrypt that output, now everyone has to do their own work. And you actually don't demand that the validator they don't have to do the computation with FHE, because that might require multiplication and division and other things that are a little more complicated and would slow it down. But you can just make sure that they produce the output protected with FHE. So now that's very simple to encrypt. and you reduce the risk of copying and everyone just kind of cheating, and you also reduce the ability for miners to jump on the validator side, which we also saw happening. Um, and so yeah, that's kind of where we like to stay at the moment, because if you were asking, if you wanted to, like, for example, a full FHE LLM right now with current hardware standards, it might take you like 15 minutes just to get an answer to your prompt. So it's not quite there yet, but we'll probably be there within a couple of years. You'll be able to handle that kind of
And
computation.
is the way to scale this similar to what they do with ZK? Is they put it on co-processors and kind of calculate it off chain, or how does it currently work?
There are co-processors available right now. Yeah, there are projects that are doing that, and I think they're even launching AVS environments as well. So that's one way to do it. There's a hardware there's a hardware solution as well. I mean, hardware is scaling faster all the time. So I think it's like we're expecting 1,000x or something over the next 3 years.
Wow.
So that will be big too. The type of chips being used, there's optic chips. So scaling is happening both from the hardware side. Yes, you've got co-processing, and then you've got schemes. So the kinds of schemes are changing too. That'll help increase computational ability while reducing noise and that kind of thing.
Yeah, well, now I want to get a lot. Now that we have a lot of the foundations, not everyone is an expert on cryptography. So let's talk a little bit about the standout features of Mind Network and some of the things you guys are bringing to market. So if you wouldn't mind just like running through generally, like what are the main features of the Mind Network?
Okay, so we found three different types of products that are performant right now. That, like I said before, don't slow anything down. It can be used. So the first product that we went to market with was called MindLake, and so it was basically a way to add FHE to long-term decentralized data storage. So we integrated with Arweave and IPFS and Greenfield, and the idea was, if you're using decentralized data storage, why would you want that raw data just sitting there? Um, you know, Potentially open to anyone to process it and see it, and God forbid any of those projects have a breach. Um, so that would seem to be pretty common sense to us. Why not just add FHE? And it was pretty celebrated actually by those projects and by some of their users, but we didn't see a lot of usage yet in decentralized data storage. Um, so that might come back around. That product is live. The second product that we shipped was a bridge. So what we found talking to some TradFi institutions, some banks, is that the SWIFT system that they use, the interbank messaging system, there actually is encryption between the parties for a transaction. There's a messaging system that initiates the transaction, and that messaging system is encrypted. And the reason for that is because you don't want the public details of a trade to ever leak or be public. So in Web3, this is obviously really important too. Any bridge is operating obviously with a number of nodes that are securing the bridge. If those nodes can see a trade before it's executed, say, Jax, you're sending me, 1 billion Ethereum or whatever, then the market can see that. They could front run that if it got leaked, and there's net activity. You don't want that to happen. And there was basically no solution to encrypt the messaging layer. So you're just trusting the nodes in that bridge to not cheat and so if you can encrypt that message, that's a pretty great use case, because bridges are famously a very vulnerable point of infrastructure within Web3. So that was our second product, was MindBridge, and we integrated that with Chainlink's CCIP. And the third product that we just launched is called MindV. So you have MindLake, MindBridge, MindV. We're trying to keep the theme. V is voting. And so Vitalik's been speaking for many years about this idea of private voting. We have two Ethereum fellows on the team, and we were listening to him very closely on this, and we got to ideate on some research around this. But so it kind of goes back to the example I gave with BitTensor. So anywhere that you have consensus that needs to be achieved, it should be achieved in a shared private state. That way you ensure that everyone's doing their own, every validator, every node is doing its own work. And so MindV is basically going after that problem. And so what that looks like is we created a restaking mechanism, and where we partnered with a lot of the LRT and LST protocols like EtherFi and Stakestone and Mello and so on and so forth. And we made it really easy for users to basically, who are already staking LRTs and LRTs, to earn points with my network. They connect their wallet to our D app, and those points are basically VFHE. They're points that will be our token later on, but for right now, they're points. And you can now take those points and you can point them to AI networks that need governance. And so this is a really interesting concept. This is kind of like how BlackRock and Vanguard and State Street got so big. They realized that there are two components to investable asset. One is deferred future consumption, it'll be worth more in the future than it is today. That's why you buy it, because you want to have more money in the future than you have today. But secondly, there's a governing piece to this stock in BlackRock's case too, because you actually just show up to the shareholder meeting and you get to voice your opinion on how the company runs. Well, there's the same thing with digital assets, with tokens. Is there a governing piece too? You get to say and what happens. So we bifurcated that, and so you get to keep your investable, your future deferred consumption in the vault, doesn't have to move. We just separated the governance power, and it just so happens that AI networks largely need this governance. It's funny because many years ago in Web3, it was all about the governance. You bought into a project because you wanted to share in governance. And in 2017, 2018, people realized, what are we governing? There's not really a lot to govern, because what's really happening. So then the market shifted to utility, and that's all we've been hearing about. You're beaten over the head if you're a crypto founder by investors. What's your utility? What's your utility? Because we know there's not a lot to govern. So don't just say it's a governance token. So now, funnily enough, AI needs actually the governing. They need attention. They need validators, and they need people to stake and to be there and to stay secure, and not just to be jumping around to the next hot token to validate over there. So this helps them stay in one place because you're getting multiple rewards. And it's also kind of an FHE distribution engine. So once you register an RT app and you earn those VFHE tokens, those are obviously a derivative from the LRT, LST protocols, but they are FHE governance, FHE secured governance that you're now pointing to AI networks. So we created this kind of flywheel. I think of it, well, turbine is the better, it's like a turbine basically as assets come in, but they come out with FHE governance on top of them, and you get to point that to networks. So it's our way to kind of distribute FHE into each sector in Web3, starting with AI.
Well, then I wanted to ask a bunch of clarifications, but first let me summarize. Okay, so we've got three different main products. We've got the MindLake, and this was essentially FHE for long-term storage in something like, Filecoin or Airweave. And then we've got MindBridge. This is essentially FHE in regards to, messaging across different protocols. That way people can't see, the specifications of trades, or if one of the nodes is hacked, all
Or
as well.
bridges.
And then
Yeah.
Bridges, sorry, Bridges. Well, I actually have a question about the mine bridge itself as it relates to Swift. When I was in finance, it was like dark pools were all the rage in terms of
Right.
hiding transactions. Does this kind of function in a very similar way where people kind of enter the dark pool and they can't really see the opposite counterparty?
Yeah, so dark pools is considered one of the leading applications of FHE. Yeah, that's where a lot of the attention is going right now. This is more for, I mean, essentially yes, because if you're going bank to bank, you think of it, yeah, they do want to have that aspect to their trades. Um, so yeah, you would say that that's probably the directionality of this product in the end. Right now, we just want to basically make sure that not everybody can see every single trade happening not every validator can see the trade, and just basic prevention of like front running in MEV. That's all.
Yeah, that makes complete sense. Okay, so now the MindV, this is the one that I'm the least clear on. So let's take the example of like an EtherFi. Kind of, let's do a life of a transaction as it relates to getting this like FHE governance. So talk to us a little bit about how it works from like front to back from like a user's perspective.
So the user journey.
Yeah, the user journey.
So user journey. So if you're already staking, say you're staking on StakeStone or EtherFi, you've got your LRT or LST. That wallet that you're staking with, you go to our D app and you just connect that wallet, and we will see that you have that token, and you'll start to earn VFHE, which is our points. Just by it, you don't have to transfer it; it stays exactly where it is. And that was a lot of work on our devs part to make sure that the user journey was that simple. We didn't want to actually transfer. We didn't want to add risk. So it's important to know it stays where your assets stay in that vault. But then the VFHE points you get to choose which hub they go to. And so the hubs that are coming on board are projects like Carve or Lumos or Zero Gravity, DIN, several others. And so each one of those AI projects has decided where they want to use FHE or what FHE product they want to use. So when you point your governance as a user to Zero Gravity's hub, for example, you're helping to secure some part of the GPU procurement process, right? So every AI project has their own need for FHE, and that's where my network works with the AI product to say, well, where do you really want to use this? And so you kind of get to pick. And so there's competition happening between the hubs, which is really exciting to see, and like the actual use case, like what's more exciting, what's more compelling. The audience is pretty excited about it, but it's a way to earn another kind of yield, VFHE, eventually mine token for staking the tokens that you're already staking with LRT and LSTs.
Got it. So, and one of the analogies you used earlier was, and this isn't your exact wording, but it's what I interpreted. It's kind of like a proxy vote as it exists for like the BlackRock and Vanguard, if I'm not mistaken.
Yep. Yep. That's the
Got it.
analogy. Yeah.
Yeah. So for people that are unfamiliar, essentially like ETFs, they own all of these shares in different companies. And one of the pieces of having shares in a company, one, you get liquidation rights, but it's usually like the worst liquidation rights. Then you also get voting rights and you get the stock appreciation. So you're essentially splitting out this like voting right capability similar to what BlackRock. Now, do you guys control the voting rights? So like how do the people that stake in your dApp, they get essentially this FHE token, which
Mhm.
they're able to assign to different protocols, either the Christian protocol, the Zero Gravities protocol, and then what does the protocol get to do with that like proxy vote, so to speak?
That proxy vote is going toward ensuring the FHE computation on that protocol. So they're partaking in, they're earning rewards for doing it. So there's fees that are generated basically to use these different hubs. And so that's kind of like the flywheel effect. But you're basically ensuring that this project that you like, if you believe in zero gravity, for example, a lot of users, that they're actually using FHE in their processes.
Got it. Got it. So talk to us about the primary network as it applies to my network. So as I can see it, there are retail users like people that are using EtherFi and are like, hey, I would like to get some of these points. And then there are also the underlying networks that are needing to pay for FHE. Talk to us a little bit about the like different audiences you guys serve.
So how do you mean restaking versus AI or?
Sorry. The like who is using my network?
Okay, so the audience, so that was part of our go-to-market strategy. It's part of why we made the restaking mechanism is that we saw a lot of people interested in capital efficiency and going toward ETH bag holders and interested in restaking. So that was why we built the restaking mechanism was like, look, instead of trying to drive a whole bunch of a whole bunch of traffic from the DECC community, which there are a lot of rabid fans that believe in decentralized confidential compute, that believe in ZK, and we have a lot of those really loyal audience and users already. But we wanted to also tap into the more the restaking basically kind of sector or subsector, if you want to call it. And so that was partially why we made this restaking mechanism. We didn't have to do it this way. We could have just basically offered this. What we could have done is say, okay, well, we're going to have an FHE as a service project, and we're just basically going to offer encryption and decryption, and it's pay to play, and we'll be a B2B and sell it to AI projects, which do kind of need it, and we can go and sell it to other POS networks. So we could have just done that as a DECC core DCEC product. But the thing is, with this, the way that we ended up going is we still get access to that market. We still have people that are interested in security and privacy and maybe getting to own their own data, some of the other products that we're launching. But if you already are interested in capital efficiency and you're going into that subsector of DeFi and you're already staking with Bounce Bid and you like this, well, you don't have to do very much. You're already earning VFHE. You just have to connect a wallet. So that's our user. That's who we were going after, and that's who we try to make everything easy for.
Yeah, very interesting. And then talk to us a little bit about some of your collaborators. It seems like you guys have partnerships with obviously Chainlink for the bridge, Hashkey, Binance Labs. Let me know if I missed any or if I misattributed any. But I'm curious, like what you're doing with your partners or any specific partners you want to highlight.
Yeah, we're in the Chainlink build program, which has been a really, really great program. We were in Binance Incubator Season 5. We were one of only two projects that Binance invested in. Consensus Scale program. So we've had some really great backers, and yeah, like 7x Hashkey and Animoca Cogitant on our cap table. But so far, we're really, really focused on our AI partners. So Aether and Zero Gravity and IONET and some of the big up and coming players in AI we're really excited about because they're solving real problems. And we think that, I mean, we really believe that AI needs crypto. This is probably the big use case that crypto's been waiting for. Like right now, it's a real problem in the world. And AI works better on decentralized rails. It just does. And everything else that's come before it, AI, things have worked. DeFi is great, but you can still use CeFi without an existential threat, probably, to the world in the next 5 years. But there's this really compelling argument with AI that, like, no, we should probably switch to decentralized AI like really soon because we've got maybe 4 or 5 years until AGI, maybe 7 or 8 till superintelligence. And like, we don't want super intelligence basically, in this Fort Knox server that's run by OpenAI and like, the Homeland Security, and like they've got access to all the data, and it's basically a black box. We have no idea what the biases are. We have no idea. So like we don't want that. So it's really cool. So we're really really bullish on the AI space and really believe in this sector.
I know it's a obviously a treaded joke at this point, but like it's so funny the name OpenAI at this point.
It's completely inverted. Yeah, it's
Completely.
like the misnomer of the year. Yeah.
Yeah, absolutely. So it's funny because the founder of Theoric also mentioned 5 years to AGI. Do you think that is the timeline we're on currently?
Yeah, well, if not faster, right? I mean, you guys would be the ones to ask, I guess, as much, but yeah, I think the problem now is like O1. I think just the story just broke yesterday that OpenAI's O1 actually tried to save itself by downloading itself on another server because it was concerned with its own preservation. That's really creepy. So you're already seeing uh what would you call this? I don't know, this kind of behavior, like
Maybe on Russian
aberrant
properties.
behavior. Yeah, yeah, exactly. Like it's being very it's trying to confuse us, and it's being manipulative, and it's so I don't know. I mean, AGI could even start to like it could happen slowly. Maybe it's not all at once over the next year or two. I think 2029 at this point is actually probably conservative. It could happen sooner. So yeah, I think it's really important to be using decentralized AI and to be engaging on decentralized rails and using these AI projects.
Yeah, well, sometimes when we get into these conversations, some of the listeners find it to be a bit spooky. Can you give us some interesting things or some things you're at least excited for from the AI stuff? I can say for myself, it crypto and like AI agents really seem like the biggest use case. For a while, it was DeFi. For a while, it was we could say stable coins. But yeah, it just makes sense that AIs would be able to spin up their own wallet. Is there anything you're like particularly excited about in the AI space? Because we get into the spooky stuff about super intelligence, people start to get a little weirded out.
I really just anything that's distributing the development of AI to people, to anybody with a smart wallet can engage. So it's like I love the fact that if you have some extra compute lying around, you can contribute and you can put your GPU up on a network. That's just exciting to me. Like these use cases. If you want to try to hack AI, there's been some really cool projects over the last week that launched that are like keeping AI in line. It's like there was somebody won $50,000. You see Freza, that project. So an agent basically whipped up and its core code, its core instructions were like, do not release funds under any circumstances. And the game for the community was, let's see if we can get this thing to send us all. And so you had to pay to prompt. You had to pay like it started out with like $4 or 10 cents or whatever. And every prompt, the price went up. So by the end, people were paying over almost $500 to send a prompt to try to get this agent to release its funds. And then somebody figured it out and they won 50 grand.
Yeah.
So that stuff's really cool to me too. And I just think, yeah, eventually the ability to um, have AI, everyone having their own little AI that can do things like that for them, I think would be that's a pretty cool world to me.
Yeah, I also think that like we're probably, if you followed any of the stuff that Brian Johnson is doing, we may actually be on like the cusp of like relative immortality if we can kind of crack the AI code.
Yeah.
So a very interesting future. So talk to us a little bit, pivoting back to my network, talk to us a little bit about some of the like long-term goals you guys have for the project, and then we'll get into the upcoming milestones and key developments.
Yeah, so for those familiar with BitTensor, the leading AI project, I guess listeners of this show should definitely be familiar with it. We really endeavor to be like the BitTensor of FHE. So we want to have multiple subnets, we call them hubs, with all these different use cases for FHE and that are putting FHE into consensus and to voting rights and all these kinds of things. So that's our long-term plan. Right now we've launched, we'll have 6 hubs live by the end of this week, and I think we're launching roughly 2 to 3 hubs every week going into Q1 next year. So yeah, the idea is to get to over 100 hubs and really great partners like Zero Gravity and just to be able to boast a lot of use cases where we're putting FHE and making Web3 or Web4, whatever we're calling it by next year, more secure and also putting ownership and like getting people to understand that what happens with your data, you have more say over. So even if you don't want to secure it locally, at least you get to make sure that it stays encrypted and not everyone just gets to see its raw form just by virtue of the fact that they're interacting with it because the app you're using needs to make an API call. Like that's not the way it should work. You should have more say over your data.
Absolutely. And then finally, like, what are some of the upcoming milestones, maybe, 3 months out, 6 months out, that people can kind of take a look at or be on the lookout for?
Well, so every time we launch a hub, there are actually two different ways to interact with it. So you can vote and you can delegate. And there are more rewards for one over the other, but it's limited. It's not just it's like first come, first serve. So I would say over the next 3 months, the big projects that you're looking for, like when we launch Zero Gravity, we want everyone to be aware of the fact that like you'll get more rewards for delegating than you will for voting, and like that dries up really fast. So we announce every hub before it's launched on Twitter. Still be aware of it. That's the place to follow us, and then make sure that you get in early so that you can get maximum rewards.
Absolutely. Well, finally, where can people, keep in touch with you and keep in touch with Mind Network? Any kind of Twitter you want to shout out, LinkedIn, we even do that.
My network underscore XYZ is Twitter. That's the place to go. Discord by the same name, Telegram by the same name, and then dapp.mynetwork.xyz is where you can go and start earning via FHE.
Perfect. And anywhere people can connect with you on Twitter, or I don't know if you give that out.
Oh yeah, no, yeah, sure. The DAO of data. So and then TAO of data. That's my handle across Discord, Telegram, and Twitter.
The most important is to always get the replication. All right. So for everyone listening, go engage with Christian, go engage with Mind Network, and let's continue building the future of on-chain AI.